Have you ever wondered how likely it is for you to win the lottery, or what the chances are that it will rain tomorrow? These are questions that involve the concept of probability, a fundamental idea in mathematics and statistics that measures the likelihood of an event occurring. Every day, our lives are filled with situations where probability comes into play, sometimes without us even realizing it. For instance, when we check the weather forecast in the morning, we're actually dealing with probabilities. If the weather report says there's a 75% chance of rain, we're more likely to carry an umbrella with us. Here, the probability of rain influences our decision-making. Similarly, when we consider participating in a lottery, we are dealing with probabilities. We might hear that the odds of winning the lottery are 1 in a million. Although the chances are incredibly slim, the possibility of that one lucky draw can be enticing enough to convince us to buy a lottery ticket. Even our daily commute involves probability. If there's a 50% chance of traffic on our usual route, we might decide to take an alternate path. This decision is based on the probable outcome of getting stuck in traffic. Probability also makes its way into our conversations and plans. When planning a picnic, we might say, if it doesn't rain, we'll go to the park. Here, the decision to go to the park is conditional on the event of it not raining, another concept from the world of probability. In essence, probability is not just a mathematical concept confined to textbooks. It's a part of our everyday life, subtly influencing many of our decisions. Whether we're deciding to carry an umbrella, buy a lottery ticket, choose a route to work, or plan a picnic, we're constantly making decisions based on probable outcomes. As you can see, probability subtly influences many of our daily decisions. But what exactly is probability, and how can we quantify it? Well, probability is a fundamental concept that quantifies how likely it is for a specific event to occur. It's a measure of uncertainty, a tool we use to navigate the randomness and unpredictability inherent in our world. Now let's imagine a world where everything is either entirely certain or utterly impossible. In this binary world, we could represent certainty as the number 1 and impossibility as 0. In the realm of probability, we use this same scale. A probability of 0 means an event is impossible, it's not going to happen. On the other hand, a probability of 1 signifies an event is certain, it's definitely going to happen. But of course, our world isn't binary. There's a whole spectrum of possibilities between the impossible and the certain. That's where the numbers between 0 and 1 come in. A probability of half, or 0.5, means that an event is equally likely to happen or not happen. As the probability gets closer to 1, the event becomes more likely, and as it gets closer to 0, it becomes less likely. Now let's consider a set of all possible outcomes for a particular situation. This is what we call a sample space. For example, if we roll a 6-sided die, our sample space consists of 6 outcomes: 1, 2, 3, 4, 5, and 6. In the world of probability, the sum of probabilities for all these outcomes is always equal to 1. This makes sense, right? After all, when we roll the die, we're certain that one of these outcomes will occur. So there you have it. At its core, probability is a measure of the likelihood of an event, expressed as a number between 0 and 1. It's a fascinating concept that helps us quantify uncertainty, providing a mathematical framework for reasoning about randomness and chance. So, probability is simply a mathematical way of expressing the likelihood of an event. Opening. How do we calculate the probability of an event? Well, there's no one-size-fits-all answer because the calculation largely depends on the nature of the event in question. That said, there are 3 main approaches to calculating probability: classical, empirical, and subjective. First, let's delve into classical probability. Picture this: you're rolling a fair 6-sided die. Every side from 1 to 6 has an equal chance of showing up, right? That's a 1 in 6 chance, or roughly a 0.167 probability for each face. This is the essence of classical probability. When outcomes are equally likely, we can calculate the probability by dividing the number of favorable outcomes by the total number of outcomes. Next up, empirical probability. This is where we venture out into the real world and base our calculations on observed outcomes. For example, if you recorded the results of flipping a coin 100 times and it landed on heads 50 times, the empirical probability of getting heads would be 50 out of 100, or 0.5. It's all about what happens in practice. Lastly, we have subjective probability. This approach is a bit different as it incorporates prior knowledge and updates probabilities based on new information. For instance, if you're predicting the likelihood of rain tomorrow, you'd factor in today's weather, recent trends, forecast reports, and maybe even your gut feeling. This is the realm of Bayesian or subjective probability. While these approaches might seem distinct, they often intertwine in real-life scenarios. For example, a weather forecaster might use classical probability based on historical data, empirical probability based on recent weather patterns, and subjective probability based on their experience and intuition. In conclusion, the approach to calculating probability can vary. It could be as straightforward as counting equally likely outcomes, as empirical as observing real-world events, or as intricate as making subjective assessments based on prior knowledge and new information. Closing. Whether through equally likely outcomes, real-world observations, or subjective assessments, probability provides a structured way to deal with uncertainty. What if we want to consider more complex scenarios involving multiple events? Well, that's where advanced probability concepts come into play. Let's start with conditional probability. This is the probability of an event occurring, given that another event has already happened. For instance, imagine you have a bag full of red and blue marbles. The probability of pulling out a red marble first might be 1 in 4. But what if you've already pulled out a blue marble? The probability of pulling a red marble now changes because the total number of marbles has decreased. This is conditional probability in action, denoted as PAB, or the probability of A given B. Now let's move on to the multiplication rule and addition rule. These are essential tools in probability calculations. The multiplication rule helps us determine the probability of the joint occurrence of independent events. For instance, if we want to know the probability of rolling a 6 on a die and flipping a coin to heads, we multiply the individual probabilities of these independent events. That's 1/6 for the die roll and 1/2 for the coin flip. So, the joint probability is 1 in 12. The addition rule, on the other hand, is used when we're looking at the probability of at least one of several mutually exclusive events occurring. Suppose you're playing a game where you win if you roll a 1 or a 2 on a 6-sided die. The addition rule allows us to add the probabilities of these two mutually exclusive events to find the total probability of winning, which in this case would be 1/3. These concepts further refine our understanding of probability, allowing us to tackle more complex scenarios. By using conditional probability, the multiplication rule, and the addition rule, we can make more complex predictions and better navigate the world of chance. So, whether you're trying to win a game, make a business decision, or predict a natural phenomenon, these tools can be incredibly powerful. So, where do we use probability in real-world applications? You might be surprised to find out that probability has a hand in many different fields, and it's not just confined to the realm of mathematics. Take risk assessment, for example. In finance and insurance sectors, probability is utilized to assess the likelihood of certain events occurring, such as market fluctuations or insurance claims. This information is invaluable in helping companies make informed decisions and manage risk. In the field of statistics, probability forms the backbone of many statistical methods. It's used to interpret data, make predictions, and design experiments. Ever wonder how pollsters predict election outcomes or how scientists interpret the results of a clinical trial? They're using probability. Moving forward to the digital age, probability plays a pivotal role in machine learning and artificial intelligence. Algorithms use probability to make predictions and learn from data. For instance, your email spam filter? It's using probability to decide whether an incoming email is spam or not. Furthermore, in the realm of artificial intelligence, probability helps AI systems make decisions in uncertain environments. From autonomous vehicles navigating through traffic to voice assistants understanding your commands, probability is at work. And it's not just these fields. Probability is used in a myriad of other applications. Meteorologists use it to predict the likelihood of rain. Casinos use it to set odds for games. Even your Netflix recommendations are based on probability. In all these examples, understanding and utilizing probability is key to making informed decisions. It allows us to quantify uncertainty, predict outcomes, and manage risk. Whether we're aware of it or not, probability is woven into the fabric of our daily lives, helping us make sense of the world around us. In conclusion, probability is far from a dry academic subject. It's a practical tool that we use daily, whether we realize it or not. From predicting the weather to designing algorithms, probability helps us navigate the uncertainties of our complex world.